Hello, my name is Dr. Katy Sheen, and I'm a lecturer in Geography and Environmental and Marine Science at the University of Exeter. As a polar marine scientist, I'm one of the lucky few people to have visited this place. This is Borgen Bay in Antarctica. It's a spectacular and otherworldly landscape. Mountains the size of Snowdon surround this ice-strewn bay, and vast rivers of ice drain into it. But one of my most distinct memories from working here cannot be captured in a photo or a video, and that's how quiet and peaceful it is, at least on a still day like this. It feels pristine, isolated, and totally untouched by humans. And in fact, this is one of the few places on Earth that nobody actually owns because it's protected under the Antarctic Treaty. The first person thought to have stepped foot on Antarctica was an American sealer called Captain John Davis in 1821. And following this initial period of exploitation, there were very few visitors to the Antarctic continent over the next century. It wasn't until the early 1900s that interest in the Antarctic continent was reignited. And this is where characters such as Scott, Amundsen and Shackleton come into the story. This is an image here of Shackleton's ship, the Endurance, trapped in the Antarctic ice, from which he famously rescued all of his crew. These men went through unimaginable hardship for scientific and geographical discovery and adventure. If you're unfamiliar with the stories and of their voyages to the south, then I really recommend you read some of the accounts because they're both fascinating and humbling. Their journeys of discovery, adventure, and survival. And in fact, this is highlighted by Shackleton's supposed newspaper advertisement in the 1910s, for which he was trying to recruit men to go with him on his expedition to the south. It read, "Men wanted for hazardous journey, small wages, bitter cold, long months of complete darkness, constant danger, safe return doubtful, honour and recognition in case of success. E. Shackleton." I can assure you that Antarctic research today is much easier than that. Thanks to these early explorers and the men and women who have followed in their footsteps ever since, we now have a much better understanding of the Antarctic continent. However, its remoteness, hostility, and majesty still means that much of Antarctica eludes us today, and there's much, much more to be learned. One thing we do know is that despite the lack of human presence, Antarctica is not sheltered from our influence. And in fact, our actions, such as burning fossil fuels thousands of miles away, are having a large impact on Antarctica. This landscape is changing and fast. This area of Antarctica here, known as West Antarctica, if I can find it, this area here, is one of the fastest warming regions on Earth. And it's thought that it's warmed by almost 0.5 degrees during my lifetime. Now, in some senses, 0.5 degree doesn't sound like very much, but these small background temperature changes are having a major impact on Antarctica. For example, the winter sea ice season in Western Antarctica has shortened by approximately 3 months since 1979, and that's the equivalent of our summer weather stretching all the way through to Christmas time. Borgen Bay, the image which I showed you at the start of the talk, is situated here on the Antarctic Peninsula. So this is this string of mountains which pokes north from the main continent. And Borgen Bay itself is seeing very rapid change. The ice front here has retreated by about 3.5 kilometres since the 1950s. It's literally disappearing before our eyes. It's melting away. Because of the rapid changes that are happening here, In recent years, a team of physicists, geologists, chemists and biologists, led by the University of Exeter, have paid repeated visits to Borgen Bay over the last few years, with the aim to better understand the marine environment there and to understand why and how it's changing. Here's a picture of the team analysing some mud samples from the bottom of the seabed. Now, as a physical oceanographer, I joined the team in order to measure the water within the bay. And we did this by deploying instruments off the side of the ship, which was the RRS James Clark Ross, and she was our home for up to a month at a time. And we were measuring the temperature, the saltiness, the current flow, and the turbulence within the bay. What did we find? Well, it's still very early days and we're still analysing the results. But one thing we do know is that there is a deep, warm body of water which is entering the bay. And I'm going to show you a demonstration now to try and demonstrate what we're interested in measuring in this bay in Antarctica. So this orange water here is representative of this deep, warm, salty water which we find in the bay. And the blue water is representative of the cooler, fresher water which sits at the surface in the bay. And what we're interested in trying to understand is how the heat that's being brought into the bay with this deeper, warmer water mass is being pulled up through the water column and underneath the ice where it can instigate melting. At the moment, these two water masses are separated by this barrier. And what I'm going to do now is I'm going to pull up the barrier and I want you to watch what happens, how these two water masses mix, and in particular, look at the boundary between these two water masses. Okay, so here we go. So what you can see is immediately this red water sits underneath the blue water, and that's because it's saltier, which makes it heavier and denser. And then you can see that we're getting this wave setting up between these two different water masses. And associated with that wave, if you look carefully, you'll see these regions of small-scale overturning or turbulence. What these small-scale overturns are doing is they're actually mixing some of this red water with the blue water above. And in doing so, they're transferring some of the heat and salt from this deeper water mass upwards. So it's these kind of small-scale turbulent measurements which we're interested in observing within Borgen Bay. And we're also interested in the kind of processes which might be generating turbulence like this within the bay. So, for example, this might be the sloshing of currents over underwater hills and ridges. Better understanding these processes is really important because it's going to enable us to predict what's likely to happen in these unique landscapes. The faster they change, the quicker ecosystems there are going to have to adapt. How will the whales and the penguins and the krill cope? And what about the less familiar life forms, like these densely packed, weird and wonderful creatures that we photographed on the bottom of the seabed in Borgen Bay? So one thing we're also interested in is how the ice retreat in this region is impacting these kind of benthic communities. One other thing to note is that these changes we're seeing in Antarctica are not just going to have an impact locally, they're also going to have an impact globally. These signatures of change will be felt far and wide. They're carried across the globe by our oceans and our atmosphere. So although Antarctica can feel very isolated and remote, in fact, the climatic changes which are happening here will likely affect all of our lives in the future. So there's a lot of important work to do for future polar scientists. And if you're interested in continuing some of the work which Shackleton started 100 years ago, then please do consider applying for some of our degree programmes at the Penryn campus and University of Exeter. For example, our geography course, our environmental course, our geology courses, and our new marine science course. For example, I teach a module specifically about Antarctica and the Southern Ocean, where we discuss some of the cutting-edge research and, for example, the work we've been doing in Borgen Bay. And if you do have any questions, please feel free to drop me an email. Many thanks for listening.